Hi, my name is Steve, and one of my passions is RF, amongst other things, and today I'm going to explain velocity factor and quarter wave stubs. What we have here is a length of cable. It's around about 600 millimeters long. Now I've included the length of the connector as well, the connector adapter. And there's the length of cable. It's an open-ended piece of cable, so it would use a quarter wave stub, and we will have a look at that and see what the voltage distribution of that is going to look like. So from the waveform below, we can see we have a voltage distribution on a compared to wavelength. So obviously over here we have 0 degrees, which is the start of the cable. Here is a quarter wavelength, 90 degrees, half a wavelength, 3/4 wavelength, and a full wavelength down the bottom over here. So that's the waveform. Now you can see the voltage distribution at the top over here. It's at a maximum. So when voltage is at a maximum, the impedance will be at a high impedance. So the impedance over here will be high, and the impedance down here will be high as well. At these points over here, the impedance will be low. Okay, so the Z will be very small there and very small there, over there. So what happens with a quarter wave stub? The wavelength, the signal goes down and it travels down to the quarter of the wavelength, and then it gets reflected fully backwards, back up to the source, and it comes back again, and you'll see it comes back at 90 degrees plus 90 degrees, which is 180 degrees. And when anything is 180 degrees out of phase with itself, you'll have total cancellation. So that's why with a quarter wave stub we will end up with voltage cancellation. And at that particular frequency that coincides with, we will have a short circuit. All the other frequencies will not be a short circuit. So we won't have zero impedance for the other frequencies, but for the desired frequency you will. Now bear in mind that the notch is not very narrow, and they tend to be quite wide. So these sort of notches will produce a very wide notch. Right, so how do we go about making this? And we'll show you now on the RigExpert. Right, so there down below we can see we have the RigExpert Match. It goes up to 500 megahertz, and I've measured the cable, and it's going to operate around about between 90 and 100 megahertz, around about that area. So let's take a closer look at this and see what we can calculate. The best option to carry out this measurement is typically the Smith chart. However, I will say that the RigExpert, under its tools section, we'll get down to there later on, does have a stub tuner, and I'll show you that just after this. So what we want to do is set the Smith chart, and I've already set it, the frequency, around about 95 megs, plus or minus 5 megs, and we will sweep that. As you can see, it's sweeping through. I've cheated a little bit because I knew what it was going to be, and it's around about 95 megahertz. Now if you look very closely, you'll see down there the impedance is 0.5 of an ohm, because on a Smith chart that's 0 ohms, and that's infinity on that side over there. So we now know that's a quarter wave stub for 95 megahertz. Now the reason why it's showing it as a quarter wave stub, it's actually displaying as a half a wavelength, because what it's doing is sweeping down the length and coming back again, which is indicating 180 degrees, and anything, as I said, is 180 degrees will cancel out. So you've got to use a bit of thinking there, and you better work it out if you just understand that the cancellation takes place with two portions of 90 degrees. And 2 portions of 90 degrees is 180 degrees, which is a half a wavelength. the RigExpert does offer an alternative method, and you can go down to Tools and select that, and you can see we have a stub tuner. So let's set the stub tuner, hit that, and we'll see what that comes up. It takes a few sweeps, so we'll pause it now and look at the final result. Right, it's almost at the end. Well, it is at the end, and it says it's 94.75. Now we measured on the Smith chart, it was 95, which, you know, it's neither here nor there. So 94.67 was actually pretty close, and whatever, 94.79. Okay, so that's how we would do it using the RigExpert. Of course, the RigExpert also has the cable length and velocity factor, so we can actually look at this piece of cable. I have measured it. It's 600 millimeter, so we'll enter there, and we'll go down to here, and it's in meters, so we'll put 600 and enter, and we'll run it, and we'll see what the velocity factor comes up at. .75. Okay, well, that's interesting, because we will have a look at that, and we'll do the manual method. So we saw on the instrument that the velocity factor was 0.75. Okay. We also measured the cable. Cable length is equal to 0.6 of a meter. Okay, let's just get that into view. So we have that fact at our disposal. Now, if we go along and say, well, what does it measure? We also know that we have a stub or a zero impedance at, so stub, 94.8 megahertz. Okay, so these are the facts that we have. So we're going to put into our calculation. We know that lambda over 4 is equal to 300 divided by the megahertz, which is 94.8. So we take 300 divided by 94.8, and we end up, and divide that by 4, we end up with a cable length of 0.79. 0.8 effectively. Now we know the velocity factor is 0.75, so we times that by 0.75, and we end up with a cable length, physical cable length. Okay, our electrical cable length is this one. This is electrical, but here's our physical cable length. Measures on the calculator at 0.5933 of a meter, which effectively is 0.6 of a meter. We can round up. So we have now just proved that the velocity factor of this cable is 0.75, and we have also proved that the calculation that we measured it is equal to what we can work out electrically. So this is a little bit of a process, but however it helps us understand electrical cable lengths, velocity factor, the difference between velocity factor and, the velocity factor is the difference between the electrical length and the physical length. Okay? And that should be understood, because sometimes you just can't take your tape measure and cut a length of cable. You actually need to make sure it's electrically the right length. I hope this helps, and if you like the video, please like and subscribe.